Welcome back to part two of our workshop series on data wrangling with R. Thank you for coming back for another Friday. Before we start today's content, does anyone have any questions about anything that we covered last week? I will do a little review of what we covered last week. But before I jump in there, any questions or maybe stories about working with R this past week or anything? All right. Okay, well, we will jump in and I'll put the link in the chat to our workshop materials, the website. So there it goes. And this will be real similar to last week. So as you can see here on the webpage for the workshop, uh, we have a link to the recording from last week, as well as links to the exercises from last week and the ones from today. And we will look at the exercises from last week here in a second. But let me go ahead into the slides for part two. And I'm going to forego the intros. I think everybody here was here last week, so no need to go through the introductions. Feel free to check out last week's recording to find a little bit more about myself and my group if you're interested. I did want to show talk about some of our goals for the workshop series, both last time and today. And really, what we're trying to do here is to kind of look at the fundamentals of data wrangling. Like conceptually, what are we trying to achieve here? Like, what does this mean? And what are the steps? Because there is, it's not one thing, right? There's no magic bullet to get your data, to deal with all your data problems, right? So really honing in on the fundamentals. Hopefully by the end of today, you will have a really good feel for what functions and what packages to turn to do what you need to do to get your data in shape for whatever visualization or analysis or exporting you're trying to do. Uh, Part of the methods for this workshop is to give you some code recipes, right? So the exercises, those Cordo notebooks, they are designed to be kept, to rendered and then saved, and then you can keep them handy. So if you ever try to, if you ever need to get something done, you might remember, well, didn't we do it in that exercise, that workshop? You'll be able to find some examples. So code recipes, right? A lot of people who are programmers and data scientists, uh, they use code recipes quite a bit, right? Nobody commits all this stuff to memory. It's very few people. Hopefully, understanding the fundamentals and the practice we're doing will also help you troubleshoot your code. And wherever you're starting from, whether you're high up on the learning curve or a little bit lower, hopefully you'll learn a few things. I know some of you are very advanced users, but hopefully there'll still be some useful gems in here for you. All right. That being said, as happens with workshops, there's a trade-off between how much time we can spend on practice versus how much we can cover and how much we can cover in depth versus how high level. So you should, to really cement this, it's a good idea uh, to review the exercises and maybe work on a project that you've got where you can apply some of this. All right, so let's review what we talked about last week. So we started out by discussing tidy data, right? So tidy data, these are properties of two-dimensional data frames or data sets that are good to think about because many software programs that work with data do well with data that's tidy. And the three properties are each variable is saved in its own column. Conversely, every column has one and only one variable. Each observation is saved in a single row, and each type of observation is in a single table, right? So those are the three properties for tidy data. We looked at this example, this cases table. It's not tidy because it violates the first rule, right? The observation or the data in this table are the number of cases, and it's actually split out across three columns instead of one column. So to make that a tidy data set, we would transform it. We're going to do this today to go from a wide format to a long format, right? Uh, tidy data often has repetition and or duplication, right? So we see here the names of the countries appear multiple times. Uh, that's not that might feel like, well, that's inefficient or it's not a good way to structure your data. That's not a problem for computers to handle. Computers would prefer to have uh, a column that has lots of repetition in it because they're really well equipped to do filters and those kinds of operations. So don't be scared if you see a lot of duplication in your data. And if you have really large data, you can do things like create factors, and there's other ways to deal with if you're dealing with millions of rows and you have lots of repetition, there's ways to deal with that. Here's another example of a data frame that violates one of the principles of tidy. So here we have like a gift list, and the problem here is that the gift column has two pieces of information, not one variable, but two variables. It has a number and then an item. So to turn this into tidy data, we would have to split out that gift column into the item and quantity, right? So these are the kinds of things that we look for when we're working with our data and thinking about what do we need to do to get it in tidy. Because once it's in tidy format, you've got lots and lots of good tools at your disposal. We also talked about there's some special packages that have been designed specifically for importing data, and these are good packages to use when you're importing your data because they have import functions, but those import functions have arguments that you don't find in base R, such as, you don't have to bring in all the columns if you don't need them, right? You can select which columns. You can rename columns at the same time you're importing them. You can tell it what kind of data type, what type of class to make each column, how to interpret missing values, and things like skip rows, right? So data wrangling starts when you import your data. A package I didn't mention last week, but I would like to give a shout out is Haven package. If you're working with SPSS data, this is a really great package. It can import I think it's SAV files, the SPSS format, and it does a really nice job because if it's survey data, something like that, that's categorical data, then those questions come in as factors, right? Um, so that saves you a lot of problems. Also, we looked at dplyr last week, and dplyr is one of the core tidyverse packages. It's very central to working with data. If you want to subset rows to not use all of them, but just some of them, you can use filter or slice. If you want to sort the rows, you can use arrange. And we also saw examples of using slice min and slice max to sort as well as to take the top few rows or the top or the bottom few rows, right? And again, that's based on one or more columns, right? So good functions for row manipulations. For column manipulations, we looked at there's functions you can use to rename your columns, either rename them one by one manually with the rename function, or rename multiple columns by applying a function to them, such as to lower. We use that. If you want to pull out or subset columns, you can use select or pull. And if you want to create new columns or redefine the values of existing columns, you can use mutate. All right, so those are your go-to functions for working with your columns. If you are using mutate, we looked at some functions that you can use inside mutate, inside the parentheses, to define the values of this new column. Min rank is a nice one, and there's a couple other functions which generate ranks. If you do want to rank the values based on a column or columns, we did that for the students, see who were the top students for each quiz. And then if underscore else and case underscore when, these are two vectorized functions that you can use again inside mutate if you want to assign values based on certain conditions or criteria. All right. So those were really handy. Uh, we also looked at this string R package, which is just a handy package for various kinds of text manipulations. And these are some of the functions that we used last time. So those are good. We also today I think we'll get to it. Work with Lubridate. So Lubridate's another one of these packages. It's kind of like string R, and there's like just lots and lots of handy functions for working with dates. Another tidyverse package. If you do need to split columns, right? And we had an example of that. We had a name column, which was last name, comma, first. You have a couple options there. You can use mutate, and then within mutate, the str split underscore I. We use that to to split it and then return the ith piece of after the values are split, and then follow that up with str trim to get rid of the white space on either end of the around the delimiters. And then there's another function we saw called separate wider delim. We're going to look at that one more today because that one's a little bit more flexible. Also on last week, we used left join to basically join together tables that have a matching column. We're going to do a little bit more of that today. And then finally, we did a whole bunch of grouping the rows. And then for each group of rows, for example, for each discussion section or each quiz, you can group them. And then for those groups of rows, compute summaries, such as the average and or the max and that kind of stuff. All right. And we'll be doing a little bit more of that today. All right. So we actually covered quite a bit last time. All right. Okay. So any questions on the exercises? I did want to look at some of the challenge questions from last week. I don't know if people attempted those, but let me go ahead and exercise 1 had some interesting challenge questions at the end. So I'm just going to kind of like talk through these solutions in case people tried them. So one of the challenges, you might remember, we had a data frame that had a value for the scores on a quiz, right? So quiz 1, right? And your challenge here was to apply a transformation to this quiz 1 score um, and put it on a curve, right? So there's different ways that you can curve scores. One of them is you take the raw score, you square root it, and then you multiply that times 10. This assumes it's on a scale of 0 to 100. And essentially what this transformation does, this curve does, the lower scores come up, right? So if you got a 99, you're still going to get a 99. You can't go above 100. But this is an easy transformation to do. We use the mutate function. Oops, excuse me. Click too hard. And basically, in mutate, you simply write an expression that applies that formula, and you get your new column with the curved grade. And then we could use that to assign letter grades. All right. So easy to do those kinds of more complicated, linear transformations. Yep, and then this is just showing that curve increases the number of A's, students who got A's from 13 to 41. So that's a pretty generous curve. The other one I wanted to talk through was this other challenge number 9, where you might remember the data that we were given. There was a column called height. It's a character column, and it had a number and a unit, right? So that's kind of a challenge to deal with, right? It's a number, it's text. I presume with a height column, you'd want to get someone's actual height in a standard unit. But to transform that, and this is not uncommon, where you have data that combines a unit of some sort. So to do this, step 1 is we're going to take this column and we're going to split out the number and the unit, right? It's 2 separate columns. And once we have that, then we can apply an if-else expression to turn them all into meters, right? So that's the process here. And to do that, there's a couple ways that you can take this character column and split out the number and the unit. In this little example here, we're using the separate wider delimited function from tidyr. I'm not going to talk through this right now. You could also use mutate with that str split underscore I function like we did with the name column. But once you do have the value and the units split out into separate columns, you can apply an equation to convert them all to meters, in this case, again, using this if-else function. Okay? So if it's inches, then take the value and divide it by this conversion constant. and I had to go to Google to find the conversion constant, to go to inches to meters, and if it's centimeters, then use this other expression. Okay. One thing I will point out here, you've noticed that this this rendered Quarto document that we're looking at here, which all the exercises are these, you might notice that the names of the functions are hyperlinked. This is kind of a bell and whistle with Quarto, which you can turn on in the YAML. But basically, if you look at the hyperlinks, these take you to the help pages for these functions. So that's one of the nice features of Quarto is that you can turn that on. So for example, like separate wider delim, you're like, okay, how is this working now? I don't quite understand what all these funny arguments are. You can just go to that help page and it'll talk through what those different arguments are for. So it's one of the reasons I've taken a liking to Quarto. Okay, so much for the review of last time. Any questions before we keep going? All right, well, let's take a couple minutes here to also ask this question is, can ChatGPT just do this for us? Do we really have to like learn these fundamentals? And I'm by no means on the bleeding edge of using Gen AI tools for coding. But I am following it and I do play around and I think some of you probably have more experience with that. So let's explore this. See how can we use ChatGPT effectively? Well, obviously, it's not too surprising. It kind of depends what your goals are for using Gen AI tools. Some people just, you're in a hurry and you got to get something done by 5 o'clock and you need working code quickly. So folks are using it for that. Not saying that's the wisest way to use these tools, but some people do that. You can also use these tools, Gen AI, Claude, Gemini, and there's some others to improve your code, particularly if you're not entirely positive. You're getting it done in the most efficient or correct way, capturing all the edge cases. You can also, some people might really just, they kind of know what they want to do. Like, I want to run a GAM on this data, but I don't really like know where to start. You might work with one of these engines and say, try to figure that out. Like, what is the workflow? Like, what are the pieces that you're supposed to do? I would say I primarily use ChatGPT and Claude in the browser, so not like code completion tools in an IDE. I'm using them in the browser really as a search engine. That's just me personally. Um, I find them effective that way to look things up. But the other thing that I want to hone in on here is our goal, or at least my goal here, is to learn R. So let's think about what these tools can be used for, how they can be used to actually help you learn R, right? Because Gen AI, it can do all of these things, but how you use them will depend on what goals you're doing. So as you might imagine, many instructors out there have been playing around with incorporating various Gen AI tools or policies in their classes. Mine Setinkaya Rundle is a really well-known instructor of data science at Duke, I believe, and an avid she teaches and writes about teaching, the teaching of art. And this is a blog post she wrote from a few months ago. And here are some of the highlights and takeaways of what she concluded is that yes, you will get code and your students will get code from that's both a good thing and a bad thing, right? They will give you code. They will not say, I'm not really sure about that. Try again later. No, they will give you something. It may or may not work. If it's a simple question and it's fairly tried and true, it probably will work, right? But it may or may not be good code. That's going to be less often. Now, what is good code, right? Style, readability, it's probably going to be commented well. They're pretty good about that based on my experiences, um, but not necessarily. And definitely, you should always cross-check with the documentation. I don't believe any of these large language model engines actually run the code that they give you back. And some of them come out and say that. That's a highlight. I might be wrong there. I think they might be working on that. But her conclusion, and again, this has come from a teaching and learning perspective, is to use these tools sparingly if you're a new user, right? So if you can't really understand what they're giving you back, and if you're just kind of taking them at face value, you're not doing yourself a favor. It's not going to help you learn anything, right? Except maybe getting quick code. All right. So here would be some of my general best practices, and then I'm going to turn it over for the group to also share some of what you have found useful. I find these platforms good to get starter code, which is helpful. Sometimes I'm just struggling to find the right function argument or yeah, or to discover the function, right? I know like I want to create a Fibonacci sequence. I don't even like know what package I would start. I could, Google could tell me, these code engines would probably tell me with some examples, the arguments, and basically solving a simple, well-defined task. So I find Claude and ChatGPT, I use them both for those kinds of purposes. Good idea to break your question into smaller pieces. I would be very, very hesitant to give this a ChatGPT or another engine my whole, here's my data, here's my goal, do it for me, right? I would prefer to understand the workflow conceptually and then either work through that myself piece by piece or ask, if I do need to know the workflow, then I would ask a series of questions about workflow, not about code. If your goal is to learn, these are pretty good. I mean, the tools are designed for having a conversation. So if you're trying to understand, like what is Bayesian stats, like start from the beginning and then work towards doing simple Bayesian stats problems in R, right? So treat it more like you're in office hours. Be really wary of code that just you've never seen before. You're not even sure. Always test it, of course. And my approach here, because I used to think about, well, should we do some of these tools, use some of these engines in workshop trainings? And my feeling is the best thing I could do to help you become more effective learning art and using art is to hammer in these fundamentals, so that you can get better to both evaluate what you see back from search engines or Gen AI tools, as well as to learn from them. All right. So again, I'm not a pioneering user of these tools by any stretch, but these are my thoughts on using Gen AI tools. I'd like to pause there and ask the group, what do you find useful or unuseful, including if any of you have used them in teaching? So what are your best practices with Gen AI tools? Anybody want to share anything? Feel free to unmute, throw something in the chat. Okay, question about the ethics of them. I would agree with that one. As one of the people who writes content online that these tools are being training on, they never asked me for my permission to use my documentation. And okay, correcting errors. Yep, very much. Okay,
Sometimes I use it like a search engine. So
yeah.
to where I would have used to look on like Stack Overflow or not Stack, but what is it called?
Stack Overflow.
So yeah, Stack Overflow. Um, it can definitely search key terms and functions for well-documented things, and often they're not called quite what you expected. Like I recently found out I wanted to do some filling in ArcGIS, and the tool in ArcGIS is called Nibble, which I never in a million years would have searched for. So often, if lots of people have searched for the same thing, ChatGPT can help in a conversational style, you track something down.
Yeah, that's a good point. Yeah, for discovery, I think would be it. And then you kind of know what to start looking at. Um, all right, anything else? Understanding error codes is another one. If you have a piece of code that's generating an error code, you're like, why am I getting this error message from this piece of code? Of course, you have to ideally, you can write a reproducible problem, right? So you provide a piece of code that in theory it could run, although it's not going to. Um, um, and also report the error codes. Error codes from R and other programming languages, I don't think R is even the worst offender, are not often helpful, right? They do their best, but it's not their priority. Okay, well, if you have other ideas that come up, let me know. We've talked around about maybe teaching a workshop on how to use these tools, and maybe we will. and maybe in 5 years they'll be really, really better advanced to the degree that it'll change us more fundamentally, both how we learn it and how we use them. I do. Mhm.
Oh, I have one other thought, which is just that it does not save time.
Good point.
Fundamentally doesn't save time. It can be helpful if you need to think through a problem in a different way, but the amount of troubleshooting and work you have to do to kind of quality control, it's more like having an assistant who can do a search for you and help you kind of find information and cobble it together, but you need to understand the goal and kind of the methodology going into it to actually produce something workable. So certainly not a replacement for um, a human being.
I would absolutely second that, Janelle.
Okay. Nice. Yeah, it's kind of like a research assistant, but who's very enthusiastic, but also needs a lot of guidance.
And also will not know or acknowledge if it did something wrong.
Yes. Um, okay, excellent, excellent. Well, I'm sure we're going to be following that over. Okay, let's talk a little bit about what we're going to be covering today, starting with reshaping data, right? So you might remember last time we basically worked with quiz one there, but there's 18 columns with 17 other quizzes. So to work with them all together, we're going to have to reshape our data frame. And the go-to package for reshaping data is going to be tidyr. It's got functions, well-developed functions that can handle lots and lots of scenarios for both options, right? So you basically, if you're reshaping data, this is referring to either going from wide, where you've got lots and lots of columns, and you want to reduce those into just a handful of columns with a lot more rows. All right, so that's going wide to long, and then long to wide is going to be where you've got data that's long, which probably counts as the tidy data. And you want to go from there to a wider format, maybe because you want to display it as a table, or you want to feed it into something else, or you want to do some row-wise calculations. So you really want those rows to come out to extra columns, right? So we're going to do both of those today. So let's look a little bit more closely at going from wide to long. So this is the function that we're going to be using. And this function has like a dozen arguments, but the three main ones are calls, names to, and values to. Again, all of these are asking for the names of columns in the wide data frame that you're trying to make longer. So the calls argument, this is where you tell it the columns that you want to disappear and to be transformed into extra rows. All right, so in this case, we have this little table here. We have columns named 2011, 2012, and 2013. We want those columns to disappear, right? So that's what the calls argument tells it. The names to, so the names of these columns, so that's what names refers to, the names of the columns that are going to disappear, where should they go in the long data frame? All right, so this is probably going to be the name of a new column that it's going to create. Right, so here we're telling it, take these column names and turn them into year, right? Now you might notice, if you're observant, that they come in as text, right? Because column names are text, even though they're year numbers. So we would have to follow this up probably with another, like a mutate function to turn these column names into integers, right? Or numbers. Actually, there might be another argument you can use within pivot longer to apply transformation to the column names. Actually, now that I think about it, I think it provides that. But anyway, so we got to tell it what to do with those column names, where to put them, and then also the values of these columns that are going to disappear, where are they going to go, right? In this case, we're telling it put those in a column called cases. And there's other arguments that you could use. Sometimes the values that you're trying to move over contain like two variables, like for example, case hyphen something else, maybe a province or something like that. There's functions you can use to split those out at the same time. We won't go there. All right, but it's not that hard, right? So once you figure out and you've got an example, it's not too hard to do this pivot longer. Pivot wider, we're also going to do this later today. And same kind of deal, right? So the function called pivot wider, we have to tell it what are the ID calls. So that's basically what are the columns that you want to keep, right? So you're going from long to wide, and we want to keep some of these columns. That's kind of like the columns that identify a row. The names from is basically it's going to create new columns that you're telling it you want new columns. That's what it means. So where are the names of those columns going to come from? So what column in the long frame to become the names of new columns, and then where to get the values from, where to get the values. So that's how pivot wider works. So we'll see examples of both. The tidyr package has a nice vignette on many other cases, more complex cases, if you do find yourself needing that. Okay. Something else we're going to do in the first exercise coming up here is work with missing data, because that's part of working with data and certainly part of working with research data. So question number one is, how are those missing values encoded? Sometimes, and again, it depends on where the data came from. It might depend how you imported it. Sometimes they're encoded with a number, an implausible number like -99. Sometimes it's an empty string. Sometimes, hopefully, it's been brought in as NA, right? So R has a special symbol, I would call it, that represents missing, right? So R has a handful of these special symbols. Null is another one, NaN is another one, but NA is R's symbol, which represents something is missing. Doesn't necessarily mean it's a mistake or an error, it's just missing. And those import functions from readr, readxl, they have arguments to tell you if there's an empty cell in Excel, make that NA, right? Or not. So that's question number one. To see how many you have, you could use the summary function. There's also this isNA function, which it's vectorized, and it'll return true or false if what you pass to it is what is the NA missing value. All right. And of course, the exclamation point or bang operator flips that. So true becomes false, false becomes true. And of course, you probably know you can sum up logical values to get the number of true values, right? That's a little trick we use a lot. Okay, so now you know, okay, I do have some missing values. So the question then is flipped back to you. What do you want to do about them, right? So you've got some choices here. One choice is basically to just ignore them. So you can't ignore them if you want to compute summary statistics like mean, standard deviation, min, max, that kind of stuff. But all of these functions, they do have an argument that you can throw in there to remove those NAs and just basically compute the mean of all of the non-NA values. All right. So if your values are encoded with the NA symbol, this works. And this is what we've been doing. This is what we did last time. We were just kicked the can. We didn't do anything with those NA values in the scores. Another option, which might make sense depending on your use case, is to just drop the whole row, right? It's an incomplete observation, so we don't want to keep working with it, right? So you can drop entire rows, using this function from tidyr. You might choose to replace missing values with something else, maybe a constant. And you can do that we've already seen using if else. You could say, if it's missing, give it a 0, otherwise use its current value, that kind of thing. tidyr has a function that does the same thing, a little bit more elegantly. You may also say, well, if it's missing, then take the value from another column, Same observation, but from another column. And there's a couple functions you can use to do that. Sometimes you're getting data that just has lots of gaps in it. Maybe that's how it was entered. And you can just like fill down or fill up the missing values from above or below. So tidyr has a function that does that nicely. And then finally, if you do have like time series data or some data where there's a predictable relationship between values on different observations, as you might imagine, there's lots and lots of options there to interpolate them linearly or spline or other models, and you can specify the neighborhood size. So the impute TS and the zoo packages, they got a whole bunch of functions that you could turn to if you want to replace the missing values from non-missing values in other rows. All right. So there's a pretty good tool set there. The hard part might be what makes sense for your use case. Okay, questions? All right. Okay, let's go to our next exercise. Okay, so assuming you're using Posit Cloud for the exercises, click on the link in the chat window. This is a new project from part one. So go ahead and click, and I'm going to do the same thing here. If you are using RStudio Desktop on your laptop or Positron, I'll give you the command that you can run there to download the exercises. Hopefully this will work. Okay, so if you are working on your laptop in RStudio or Positron, copy paste the command I put in the chat window, that use course command. That's gonna bring in a zip file. You can put it on your desktop or somewhere else. It's gonna unzip it for you, and it's gonna start the RStudio project in there. Okay, once you've got the project open, go ahead and if you haven't saved it already, click Save a Permanent Copy. If you see that little flashing temporary copy, and then go ahead and go into the exercises folder and open up exercise 3. Click on it, and it'll open up in the script window. And if folks could give me a thumbs up once you've opened up this new RStudio project and managed to open up exercise 3. Okay, good. Then it works, at least for some people. Never quite know. All right, excellent. If anyone's having trouble, feel free to unmute or put something in the chat window. Okay, excellent. All right, I'm going to go ahead and work through exercise 3. First thing I'm going to do is I'm going to minimize my console, because you might remember with Cordo documents, we see the text in the document itself, so we don't really need that console. And then I'll give myself a little screen space. I'm going to stay here in source view where we're seeing the markdown code. You can go into visual mode if you like WYSIWYG. My guess is it would work as well fine here, but I'm going to stay in source mode just because it's more familiar. And okay, I'm going to go into code chunk number 1. So come down to code chunk number 1, that gray box, and click the little green arrow to run it. And as you can see here, all we're doing is loading some packages. Now, what we're going to be doing in this exercise is we are going to keep working with that pop quiz data. And we're going to do some warm-up exercises using stuff that we covered last time. The first thing we're going to do is there's a character column. We're going to change the values. Then after that, we're going to pivot. We'll do that pivoting operation, do some global summaries, because now we have all 18 quizzes and all the students all together in a tidy format, so we can easily do some various summaries, and then we'll work on with some of the missing data. Right? Okay, so after you run code chunk number 1, come down to code chunk number 2, and this should all look pretty familiar. We're just importing the data, right? So it's and you can see a preview of it there. You can scroll over and you can see we've got 18 columns of quiz data, 100 students. And in that code chunk number 2, we cleaned up the names of the columns a little bit, right? So now they're all lowercase, they don't have any spaces in them, and we did that all in one expression. Okay, so code chunk number 3. So if you look at the data that we brought in, and you see there's a column called year, and it's a character column, and it has codes. JNR, SNR, we can see some more of there's also, but anyway, it's a column that has codes. And I hate these columns. We get them a lot in the world of GIS, like land use categories or soil types or administrative codes that represent something. And they're always a pain to figure out. So, but what we're going to do here is we're going to take those codes and we're going to convert them into labels like that are understandable. But number 1, let's look at the values of the code. So in code chunk number 3, go ahead and run that. Click in there. and Control Enter. And what we can see is the codes that are in this column are JNR, SNR, and SPH, right? So these are junior, senior, and sophomore, right? So we can kind of like figure that out. So let's go ahead and replace those with the full labels. So the way we're going to do that is to create a data frame that has the code and then the label, the full label, and then join it to the data on the code, because now both the tables have the same code column, and we can use that to join them together, and then we'll have the labels in the data, right? So in code check number 4, we want to create a table, which again has a column for the abbreviations and another column for the labels that we want to bring in. So what I put here in the chat window is a piece of code that will actually create a tibble using the tribble function. So just when you thought these function names from the tidyverse couldn't get any stranger, we now have the tribble function. But basically, the R there stands for row, and it's a function that you can use to create through code in this case a tibble. Right? So that it's handy when it's something you can do fairly quickly. So that's code chunk number 4. That worked. Let's then come down to code chunk number 5. And this is where in code chunk number 5, we basically join the research data to this table that we just created on the year column, which has the abbreviations. And now when we look at the results, we can actually see that we have a new column and it come in. That's what happens when you join tables, you get new columns, and it's got the labels for each of the years. Okay. So any questions? Okay. And once it's there, we could overwrite the current column using mutate. We could use if we want to make a label, or we can use that column for anything else. Let's come down to code chunk number 6. The next warm-up exercise we're going to do, and again, this is using data, all stuff that we've used last time. We're going to take these 100 rows of data, and we're going to flag some of them for training and some of them for validation, right? Which is pretty standard when you're trying to apply a model or train a model from data. You want to use some of the data, most of the data, to train that model, so you get a good model that can predict something. And then, but then you don't want to use that same data to test how good your model is, because you trained it on it, so it's going to be pretty good. So we reserve some of the rows for validation, right? And then we apply this model that we just parameterized and to the validation data, and we quantify how good it did to predict whatever it's supposed to predict. So code chunk number 6, we are creating a column. You can go ahead and run code chunk number 20, code chunk 6. We're creating a column. It's called, what is it called? It's called set. So training set or validation set. And you can see the results of it below. And you can see the expression that we're using to create it. We're using the sample function, right? Because we want these to be randomly assigned. And the sample function, the arguments are the values that you want to sample from. Size is the number of samples to pick. So we're telling it to use the n row for the whole data set. Obviously, we have to replace equals true. So that's where we're sampling with replacement, because we have to get 100 numbers and there's only 2 values. So if we don't sample with replacement, we're going to run out of values pretty quick. And then the prob argument kind of defines the probabilities of each of the items getting selected. Relocate is something we haven't seen relocate before. That simply takes this new column, which otherwise goes to the end, like after the 18th quiz. It goes way, way over there. We can use relocate to simply change the position of a column. So we're using it here so it appears right after the name column, right? Okay. Any questions? So that should be familiar, right? Maybe you couldn't do that like in 2 minutes, but you should everything that we've just seen here, we talked about last time, except maybe the relocate function. Okay, let's keep going. I think the first challenge, I'm gonna let you do that on your own. So the first challenge would be make another set column, but this time don't make it random. Simply say if you're in discussion section 1 to 3, then we're going to use your data to fit the model. And if you're in discussion section 4, we're going to use it for the validation data set. All right. So there is a solution linked on the main menu if you want to check your work, but well, you should work on that. But let's go to the next piece of the exercise, which is where finally, right? Finally, we're going to take this wide data set and we're going to make it long so that finally becomes tidy. Now, harping from the get-go, how wonderful tidy data is. And now we're actually going to transform our research data into a tidy data set, which simply means in this case, going from wide to long. So in code chunk number 8, go ahead and run code chunk number 8. We're starting with the wide data, SS_NN, which stands for nice names. And we're piping that into pivot longer. We're telling it all of the columns that start with quiz, right? So those 18 columns that start with quiz, those are the columns that we want to disappear. And we want those columns to be added as additional rows. So we're going to wind up with a pretty long data frame at the end of this. So that's the calls argument. The names too. So that's basically the names of those columns, those 18 columns. Where should they go? We're telling it, put them in a new column that is called quiz. And the values, the values of those 18 columns that are going to disappear, put those in a new column called score. And if you go down to code chunk number 9, the first one tells us the dimensions of this new data, this new tibble that we just created, 1800, right? So we had 100, and now we've got 1800, which makes sense, right? Because there was 18 columns that we nuked. And then the next line in code chunk number 9 gives you a glimpse, using we look at the first 20 rows, and yeah, you can see that all of the columns at the beginning columns are all still there. We didn't remove any of them, but now there's a new column called quiz and a new column called score. Right. So instead of like 28 columns, now we have 9 columns. Right. So we've gone from wide to long. Any questions? Okay, so it wasn't that hard to do, and now we can benefit from that operation. So code chunk number 10 in the next section, now we have all of the quizzes together. They're all in one column, so we can do kind of these global summaries of the data. So in code chunk number 10, go ahead and run that. We're using ggplot to create box and whisker plots where we're mapping on the y-axis the scores, right? That's where the box and the whiskers come from. And along the x-axis, we're telling it to create a different box plot for each quiz, right? X equals quiz. So that gives us kind of a quick glimpse of the averages of these quizzes. And it looks like quiz number 7 was much, much lower than all the other quizzes. So if we're trying to learn something about the different treatment groups and how they affect student outcomes, we probably want to throw out quiz 7. There's something funny going on there. That's easy to do though, because now that our data is tidy, if you come down to code chunk number 11 and run that, we're basically dropping all of the rows from quiz number 7. For all 100 students, we're just removing those. And that's really, really easy to do because we have a column called quiz, which is the name of the quiz. And we're just telling it filter out values, or only keep values where the value of quiz is not equal to quiz 7, right? So that's what that exclamation point equal sign, that's the comparison operator for inequality. And what we get left now is we have 1,700 rows. We had 1,800, we just dropped 100, so we're left with 1,700. And we're saving the results in a new table called SS_clean. All right, so now in code chunk number 12, if you click in there, we're just creating the box plots again, same. And now number 7 has dropped. And all the other ones look like, we see some normal variations that you might expect. Student learning. Okay, so see how easy that was? And again, this is so easy to do because now we have our data all together. So let's go to code chunk number 13 and run that. This is another simple operation to do. At the end of the semester, you have to assign student scores. So we can create the average of the students' grades or scores on all the quizzes simply by grouping the data by the name column, which is the name of the student. And then for each one of those groups, for most of them, it should be 18. We compute the average score. All right. And then if we wanted to assign letter grades, we can go back to part 1 where we did a little exercise where we converted numbers and we bin them essentially using case when and assign them letter grades that way. Okay. Any questions? All right. Let's pause here for a couple seconds and let you everybody try challenge number 2. So challenge number 2, you've been asked to compute the overall average for each treatment group, right? So you might remember the students were randomly assigned into one of 3 treatment groups, one of which was a control. And we're curious to see if those treatments had any effects on their scores. So that's what challenge number 2 is, asking you to write something that will give you the average of all students and all quizzes for each of the treatment groups. All right, very good. Okay, so we can work on this together. So the data are in SS_clean, right? So that's the last data. That's the data where we got rid of quiz number 7. And in case you want to remember what's in it, I can just hit enter and see what it looks like. But again, we want to group the data by the treatment groups. So I'm just going to pipe this into, oops. I'm going to change my pipe character. So I'm going to go Tools, Options, Code, and say Use Native Pipe Operator. So that when I use the keyboard shortcut, Control-Shift-M, it gives me the native pipe, not the older pipe. But either would work. So we're going to group by treatment, right? So we're going to group by the unique values in that column. And then for each of those groups, we're going to summarize. And we're going to, inside the summarize function, we're going to create, we'll just call it average score, AVG score, equals to mean of the score. I think there's a column called score. Come over. Yep, there's a column called score. Now, if I run that by itself, I'm going to get a whole bunch of NA values because there's a lot of NA values in this data. We haven't done anything with the NA values. So I need to tell it to remove those NA values when it computes the mean. So the NA equals .rm equals true. And we get those results. Okay, any questions? So it's looking like treatment group number 2 might be different. We saw this before with quiz 1, but now we're seeing it with all the quizzes and all the students combined. So it's less likely to be sampling error, right? Looks like treatment number 2 may have had an outcome, statistically significant outcome on the quiz scores, although we'd have to do some more statistics to verify that. Let's continue. So now we've got tidy data to work with. Let's look at the missing values because there are missing values in this data set. So far what we've been doing is basically ignoring them. So in code chunk number 15, go ahead and run code chunk number 15. And here we're simply starting to get a feel for like, how prevalent is this? Is this something we've seen them in the output, but now we're actually counting them up. So in code chunk number 15, we're basically counting up the number of missing values for each student, right? So we're grouping the data by name, and then the summarize for each group, there should be like 18 records for each student. We're telling it to add up is NA score. So is.NA is going to return true value, and then the true values will be summed together. So that's going to give us the number of missing values, which basically means they didn't show up to take the quiz that day. And then PRP, we're basically missing PRP underscore missing. We are taking the value that we just created, and then we're dividing that by n, which is the number of rows in that group, right? So that's giving us the proportion. So for 100 students, we now know how many quizzes they missed and what was the proportion of quizzes they missed. So that's the table. It's a little bit easier to view that in the histogram. So in code check number 16, go ahead and run code check number 16. And now we can see quite a few students didn't miss any, but students don't always show up to class. And there's a handful of students who missed quite a few of the quizzes. So I think about how to do that. So the challenge number 3 is how many students completed all the quizzes, meaning how many students have no NA scores whatsoever. Let's do that together, right? So challenge number 3, you've been asked how many students had perfect attendance, basically, on these quiz days. Right, so what we could start with might be, let's see, what the table we just created, SS underscore student underscore NA underscore tibble. So that tibble saves the number of missing scores per student, and we want to know how many of them didn't miss any, which in other words, 0. So I could simply pipe this into filter, right? So that we only keep the ones that had perfect score. So that would be num underscore missing double sign equals to 0. All right, so that's going to give us, whoops. Oops, if I spell it correctly. All right, so that's going to give us the results of it'll give us only back the rows for the students who didn't miss any quizzes. And if we want to, get the count of those, because that's the question, how many students completed all the quizzes? I can either just look at the output. This is a tibble with 31 rows, or I could pipe that into n row and return the number of rows. So it's 31. Okay. Let's keep going. So I'm going to let you do the next challenge on your own for homework. Which quiz had the most missing scores? That shouldn't be too challenging, right? Just have to group it by quiz instead of by student, but otherwise it's similar. Let's go to code chunk number 19, where here we're basically going to use the drop NA function from TidyR, and we're going to simply drop all of the rows where the score column has an NA value. And the last line on code check number 19 is simply showing us how many rows got dropped, right? So we're counting up the number of rows in the raw data and then the number of rows in the data that has the missing values taken out. And it goes from 1700 to 1453, right? So 250 roughly scores were removed from the data, which might be appropriate if you're doing like regression or something like that. Any questions? Okay, next, code chunk number 20. Here we're going to use replace NA, and we're going to use replace NA. So we're not removing them, but if there's an NA, the student gets a 0, right? That's a little bit harsh, but That's one way that you can handle NAs in a classroom setting. So um, let's see, I don't see any zeros in the first 20 rows. Let me go to the first 40 rows. And if there were NA values, oh yeah, so now I'm starting to see some zeros, meaning those were NAs that now the student has been given a zero. All right. I'll let you do challenge number 5, which would be like now that we've given a lot of student zeros, like the overall class average, how is that affected? Right? Obviously, it's going to come down. But I'll let you do that. That's a one-liner, right? Shouldn't be too hard. Okay, code check number 22 is this is a little bit more involved. In this scenario, we're going to replace those missing scores with the student's average score for all the other quizzes that they took, right? So that's another way you might deal with missing values is replace them with an average, in this case, of non-missing values. The way we're going to do that is we're going to, first of all, compute the average of all the quizzes they actually completed, and we're going to save that in a table, a separate table. And that's what we're doing here in code check number 22. Go ahead and run code check number 22. And here you can see for every student, their overall average for the quizzes that they actually took, right? So to use that overall average for the values of the NAs, we have to join it to the data, right? To the all the data. So that's what's going on in code check number 23. So if you run code check number 23, you see we're using a left join there to bring in that table that we just created, and we're joining them on the student name column because that'll work. And after we've done that, we have the score column, including the one that has NAs, and then we also have the overall average column, right, for that student. So now we can, in code check number 24, we're ready to go. We have the raw score column, the student's average for all the other scores, they're all together. So we can, in code check number 24, we can use mutate and if else to basically say, if the score is missing, then replace it with the overarch value. Otherwise, keep the existing score. All right, so that's what's happening in code check number 24. That would be another way, a kinder way to deal with missing values. All right. And then code check number 25 shows us with that approach, with that way, how is the overall class average affected? And it goes down a little bit, but not dramatically. Okay, any questions? Okay, that looks like a good place to take. Let's take a 5-minute break. Okay, we shall resume. Welcome back, everyone. Before we keep going, I'm going to go back to my Posit Cloud. And just as a reminder to everyone to render your document when you're done. So if you've done any of the challenge questions, or even if you haven't, if you click render, it will or should generate a HTML version of your Cordo document. It'll run all the code, whether you ran it or not. It'll run all the code in the document and then open it up in a new window. You may have to give your browser permission to open up pop-up windows. But this is the rendered document. It also appears in your file pane in RStudio. So you can download it, right? You may have to refresh your file pane window, but make that bigger. That HTML file and then the folder that has the files that go with it. That's what you would download to your laptop for your records, for your library, your code recipe library. Okay. There are some challenge questions which I would invite you to work on if you want to hone your skills, test your skills. The first one says, drop all the students who miss more than 40% of the quizzes, right? So you have to think about how you're going to do that, right? And that, yeah, I won't say more. But you've seen you can use methods that we've used elsewhere higher up in this notebook to do exactly that, right? To identify the students who missed 40% of the quizzes and then drop them because yeah, you don't want them in your study, right? Because you want to predict the efficacy of these treatments on learning outcomes, and if they don't show up to class, then they're not going to be effective. But that's a variable we're not trying to measure. And then finally, kind of in a similar way, what do these data say about the theory that coming to class supports outcomes, supports learning? So you can think about different ways you might come up with some summaries or some plots to kind of illustrate that. Okay, very good. Let's keep going then. So what's coming up next in the next exercise, because we're going to jump right back into the next exercise, is we're going to look at mutating within groups, explain what that means and why we do that. We're also going to split this table, right? So far we've been working with one big table. It's got about maybe 8 columns or so about the students, their name, their height, their discussion section, all that stuff. We don't really need to know all of that for our data analysis. In fact, to preserve privacy and make it more anonymous, we probably don't want to have those, in the same place. So we're going to take that table and we're going to split it out with the ability though to join them back together. So we'll do that. And then finally, we're going to tackle, there's another column, a text column called major. And it's another one of these columns that has comma separated values. But that one's challenging because some students have one major, other students have triple majors. So we're going to finally tackle with that column and split that out so we can actually, for example, count up how many students in each major. Okay, so that's where we're going for our next exercise. So go ahead and jump back into Posit Cloud and go ahead and give yourself a clean platform here. So I'm going to, I already rendered my quarter document so I can close it. And I'm going to use the little broom icon, clean up my console. There's another broom icon in my environment pane, so I'm going to delete all of those objects. And I'm going to now click on exercise 4. That's another quarto markdown document. I'm going to close the console. And then finally, for good measure, I'm going to come up to the run menu and say, restart R and clear all output. All right. So I trust that works for everybody, but open up exercise 4 and then from the run menu, select restart R and clear all output, and you should be good to go. All of these notebooks are designed to be reproducible from scratch, right? So that's kind of the goal of reproducible analysis. So we're working with the same data set. So in code chunk number 1, go ahead and run that. You'll see a lot of familiar faces there. We're in code chunk number 1. In the 4th exercise, we are simply loading the packages that we've been working with. Okay. And then in code chunk number 2, we are simply loading the data that we've been working with and applying the same cleanup as we've done in the past, right? So we're creating a version of the data that has nice names. So we're getting rid of the spaces in the column names, and then we're also creating the tidy version of the data where we're pivoting using the same command we used last time from wide to long. We're dropping quiz number 7. And note here, we're also dropping all of the NA values. So now this SS underscore clean underscore Tibble, it does not have any NAs. We've gotten rid of all the NAs. So we won't have to worry about those in this exercise. All right, so that's code chunk number 2. So let's go ahead and in the next section, we're going to compute the ranks. We're going to give each student a rank, but last time we gave them a rank for the whole class, right? For quiz one. Here, we're going to give students ranks for each discussion section. So each TA in their discussion section can highlight the top students in their section. All right, so that's our goal here. If you run code chunk number 3, you'll see something we've seen a lot of, where we're basically using group by to group the data by section and then quiz, and then we're following that up with summarize, right? So we've seen this a lot, and this is mostly what you'll probably use the group by for. So group by followed by summarize is very common, right? It's doing a summary or changing the unit of analysis. However, a little known fact is that you can actually use mutate. You can use group by followed up by mutate. And you would do that if, mutate creates a new column. And you would do that if the expression that you want to use for the new values of the new column should be computed based on a group of records, not the whole data. All right. So that's an example of mutating within groups. Okay, so what we can do here in code chunk number 4, we are computing getting the average for each section for each student, right? Because again, we want the ranks in each section to be based on not a single quiz, but on their average for all the quizzes. So we have to do that first, right? So now we have for every section, for every student, their average for all the quizzes they took, right? So now we're in a position to compute ranks for, again, within the sections. So if you come down to code chunk number 6, starting on line 88, and run that one, then here is where we are computing the ranks. So let's look at this closely. So on line 90, we're grouping by this section. And then immediately after that, we are using mutate. And again, we're using the min rank function to compute ranks based on the average all column in descending order. And what that's going to do, it's going to fill in values. It's going to assign a rank value, but within each group of rows. And again, these groups of rows are the sections. Okay, we're following that up with ungroup because it's still a group tibble at this point. So we're going to ungroup it. So now it's back, or it's a regular tibble. You might remember a group tibble looks like a regular tibble, but under the hood, in the attribute for the object, there are groups of rows defined. And when the groups of rows are defined, then certain functions behave differently. So that's why we're ungrouping it. And then we're selecting the 3 columns and then we're arranging them. So now what we see at the end of this is going to be the ranks of all the students in section 1. And if you go to the next page, we'll probably see the beginning. Yeah, section 2 is there as well. All right. So hopefully that was clear, right? So the goal is to create ranks within each section based on all of the quizzes. So step 1, we compute the average of all of the quizzes, but we keep the section column in there because then we follow that up with, we group on that section column, and then we compute the ranks to see who are the top students in each section. Okay, hopefully, all right, so that's good. In the next piece, we're going to split this table. We're going to take the personally identifiable information columns, and we're going to put them in one table, and then we're going to drop them from the score data, our research data. But when we want to do this so that we can join them back together. And the typical way that you do this would you create, if you may have one already, an ID number or something that is unique to each student, but by itself, you couldn't know what student that it belongs to. So in code chunk number 7, we are creating, go ahead and run code chunk number 7. We're creating this PII table. Again, these are the columns of personally identifiable information, which includes the name, the sex, the height, the year, their major, their year, and their discussion section, because we don't really need those for the research study, right? The research study is interested in the treatment group and whether or not it had effect on the scores. So everything else we're selecting, and we're saving it as a new tibble. But then if you also notice on chunk number 7, we have this mutate function, which is adding a column, which is going to be randomly selected numbers between 10,000 and 999,000. Sorry, 100,000 and 99999. So basically random 6-digit numbers. And we're using the sample function without replacement. So we'll get random values from there. And then we're just relocating that student ID column to the second column here, so it's a little bit easier to see and viewing that. All right. So now what we have is we have a table which is just the personally identifiable information. All the quiz data is dropped or wasn't kept, but it does have this unique identifier number that we can use as kind of an anonymous identity. So what do we have to do next? Well, next we have the scored data, the table with the scores, and we need to get this student ID number in there, and then we'll be good to go, right? Because once it's in there, we can now have a connection between these two tables. So in chunk number code chunk number 8, we're bringing in the ID numbers, because at this point both tables still have the name column, the name of the student. So as of now, we can still use that to join the PII table and the quiz score table. So that's what we're doing in code chunk number 8. You can see we're joining them by name. But now you'll notice if you scroll over, you'll see the student ID number, the student ID column has appeared, of course, because we joined it in. All right. So now we have it in this quiz table. So the last thing to do is now we're just going to clean up the quiz data, and we're only going to keep the columns. All we need is the student ID number and the quiz scores, and that's it. So in code chunk number 9, that's what we're doing. That select statement in code chunk number 9. Notice that's exactly what we're doing. We're saying select the student ID column, and then the treatment column, we need that as well for research question. And then all of the columns that start with quiz, that's the data. So that's dropping everything else. And then we're doing our pivot function again, so it becomes long, and we're dropping quiz 7 because we already found out that was flawed. So at the end of code chunk number 9, we have a nice little tibble called ss_anon_tbl. And this is a lovely little tibble that we can start to do our regressions and other kinds of analysis, right? So it's anonymous. All we have are these student ID numbers, and then the treatment group, and then their scores. All right. So that's easy to do, right? If you need to split your data up and or make it anonymous, there's other ways you could do this too, but this works pretty well. There are actually packages that are designed to do exactly this. Okay, the next challenge, number 1, is to use that tibble that we just created to get the scores of just the senior, the senior students. So to do that, right, their year, it's in the PII table. So to do this first challenge, you're going to have to join that PII table in the score table, so that you can use that year column as a filter, right? So that's a little bit of a hint for challenge number 1. Okay, any questions? let's pause for a few minutes and try challenge number one. I just gave you the hint. The hint is now we have two tables. We have the PII table that has the student year in it, and we have the anonymous quiz score data. They are joinable because they both have that student ID numeric value. So go ahead and try that challenge. If anyone has made progress on the first challenge, feel free to put your answer in the chat window. Otherwise, I put the little hint there. We have two tables, so I'll kind of work through it together here. Ooh, very good. Oh, interesting. Interesting. Inner join. Inner join. I like that. I'll come back to that inner join option here in a second. Okay, so I'm gonna just the way I would like to work with this kind of question is I know that I've got these two tables and I want to join them. So I'm just gonna take a sneak preview at what they contain. So we have the anonymous scored table. So, and my goal is to we're definitely gonna need that one uh, because we want to um, that's we've been asked to filter the rows from this table based on whether the student is a senior or not. And then it's that PII table that has the year column in it, which we can use to easily figure out, who's a senior. So, and these two tables both have a student ID column. So joining them should be pretty easily. Question is, in what order do we join them? In this case, it doesn't really matter. But what we could do here would be to, I'll start with the anonymous table because that's the one we really need. And then I'm going to do a left join. But we haven't talked about the different joins, and there are several joins. There's left joins, there's inner joins, there's as we've seen, there's full joins, there's anti-joins, there's partial joins. We could do a whole workshop on just working with these different types of joins. But a left join is simply where we want to keep all of the columns from the first table, which in this case is the scores. And then we want to join that to the PII table. And we could say by equals to the column that they have in common is a student ID. All right. So if I just do that by itself and run that, that's a good way to start. I can see, yep, I got all of my quiz data, and then as I scroll over, I start to see the other data they have, including their name, their sex, right? But in this is an example where all I need is the senior, the year column. I don't want to see their name and their height and other stuff, right? So I'm going to modify my expression here. And for the table that I'm joining it to, instead of just joining the whole thing, I'm going to use the select function and just join it to the columns that I want to work with. And that's going to be student ID, because obviously I have to, we need that column to make the join, otherwise it's not going to work. And then the other column that we need is year, right? So this is better because when I run this now, I do this join, I've got the year. It's right there, right? So now we're basically got that year column and nothing else, right? There's not like a whole bunch of additional columns that's going to tell me their name and their sex and their height. It's not necessary. And if you don't need those data, then why bring them in? So we got one step left. Our task is to filter. So filter is easy. We can just filter, and then the expression will be year equals to senior. I think that's SNR. All right. So I think that should do it. Yep, that looks like it, right? So all we have left now are going to be the scores from the seniors. They're still anonymous, and we can do our regression, or maybe there's different weights that apply to this subset of the population or whatever. Okay. Um, excellent. Um, yep, this looks good. In this case, inner join would work just as well. I believe inner join is where you get matching columns. You get what you get returned will be the rows where you have a match on both sides, and that applies here. There are cases though where what you're joining to, there might not be a match for every record. And that's where inner join versus left join versus right join, the way they differ in the way they handle the rows that don't find a partner in the matching table, right? But in this case, we can use inner join as well. Any questions or comments? All right. Okay, let's keep going. Next, let's look at that pesky major column. So in code chunk number 11, we can see what's in this column, right? So again, it's the student's major, and some of them are ambitious and have double or triple majors. Most of them have one major. So we want to, for example, compute the number of students in each major. So to do this, we have to take this and split it, right? We got to split the column. This is a column splitting exercise. It's a little more challenging though, because they're variable pieces, right? Between 1 and 3 majors. There may even be some NA values here, although I don't think there are, but there could be, right? So what we did before when we had, for example, the name column always had 2 pieces, last name, comma, first name. The height column, the first height column always had 2 pieces, a number and then a space and then inches or centimeters, right? So those ones were easy to split because every row is the same, every value is the same. This is different though. So we have to think, how are we going to split this? Or after we split it, basically, are we going to put the values in? Our choices are either to put them in extra columns, right? So create a column for history, a column for English, a column for sociology, or to add extra rows, right? So when you're separating a column with that's based on a delimiter or position or regex expression. There's a few ways you could do this. But if the number of pieces are variable after you split it, then you either have to put them in columns or in rows. So it's a little bit like pivoting. Fortunately, though, TidyR has a nice couple nice functions. One's called separate longer, and one's called separate wider. And there's different versions, whether there's a delimiter or a position or a regex expression that you want to use to do that splitting. But go ahead and run code chunk number 12, and then we'll talk through it. So let's look at code chunk number 12. Go ahead and run it. And you can see in the output, what we're left with is going to be the student ID, and then that major column has been split there, right? So now previously the major column had multiple values, but now it's got one value but now there's extra rows. So for example, I'm looking here at one student who appears 3 times, and she had 3 majors, right? So now she's represented 3 times because she had 3 majors. So the way we did that is using this tidyr separate longer delim function. And if you read the help for it, basically you tell it what is the column that you're trying to split. And then in this case, we're going to split it by a delimiter. So that's the comma. And then as we've done in the past, after we do that split, we follow it up with str_trim, because there might be a leading space or a trailing space after it's been split. So that's what code chunk number 12 does. So it does the job. And now we have a table which has the majors 1 it's tidy. There's, the major column has one and only one um, variable in it, one unit. So if we want to compute the number of students in each major, that's code chunk number 13. That's a one-liner now, right? We don't have to do contains or loop or something clunky like that. We've got it nice and tidy. So we just take that table, we group it by the major, and then we do a summarize, and we can see that, how many students are in each major, right? And we're counting a student as a whole person in each major. So if they have 3 majors, we're not like saying they're a third English, a third sociology, and a third history. We're just, and in this case, we're just interested in how many students are majoring in each one. Okay, so that's code chunk number 13. And code chunk number, the next one is a challenge question. Compute the number of majors each student has and save it as a column. I'll let you work on that. That's pretty easy, right? Now that we have a nice, clean, tidy table to work with that has the student ID and the major, you can easily compute for each student ID how, the number of majors they have, and then save that, and then join it to the PII table, so that that new column is available. Okay. We're getting to the end here. This is good. So our last little piece of the exercise is we're going to go from long to wide, right? So before we had 18 columns and that was wide. We went to long. So now we have, if you run code chunk number, well, it's not numbered, but on line 204 or thereabouts, we're going to see a table that we're going to produce here. Right? This is a table that you might put in a report or a slide deck, that kind of thing. So for something that's going to be looked at by people, wide is generally more easy to digest than long, right? So we've got we can easily compute, for each section, how many biology majors there are, how many data science majors there are. That's easy to produce. That's a one-liner. But to produce this table, we're going to have to take the output of that and make it wide, right? So that's what we're going to do here. And so the first step 1 is going to be to crunch the numbers, right? So in code chunk number 14, I'll go ahead and run it. And basically, we are computing for every section for how many students there are, right? We've done this like a dozen times now. Easy peasy. We simply, we're going to group by the section and the major. After we split that major column into longer rows, we're just borrowing the code that we just used above. And then we follow that up by grouping those data by section and then the major, and then compute the number of students, which is equivalent to the number of rows. And we get a tibble, which has the data that we need to make that little table, but it's not in a long format. Sorry, it's not in the wide format that we want for the table. It's in a long format. So this is the table that we have to go from long to wide, and that's what we're going to do in code chunk number 15. So go ahead down to code chunk number 15 and run that. And here we're using pivot wider. This is the first time we've seen pivot wider. We saw a slide that describes it, but the 3 important arguments, there's a bunch of arguments you could use, but the 3 critical ones are the ID calls, right? So what columns do you want to keep, right? Some of the columns are going to disappear, right? Because they're going to disappear and become new columns, new extra wide columns. But we do want to keep some of the columns. In this case, we want to keep the section column because we want to preserve that breakdown. Names from is simply the names of these new columns that we're creating. Where should they come from? What column should they come from? And then the values from, those are the numbers that we see in these new columns. Where do they come from? All right, but the output of code chunk number 15 is a tibble, which is in the format that we'd like. So last thing we would have to do is just, just print it or display it or depending, there's a cool little package called GT, which there's many ways that you can create tables in R, as you can probably imagine, depending what your output format, if it's HTML or PDF or something else. Okay. Okay, finally, let's keep going. So next, we're going to work with, in the next section, we'll do a little bit with dates. We're not going to have a whole lot of time to work with dates. There's not a whole lot of dates in this data, so that's okay. I do teach another workshop series on computing agroclimate metrics where we work with dates a whole lot because those are generally time series data. But let's work with dates. So in code chunk number 17, we are importing another table, right? So another tab separated value table. And if you look at what that looks like, we have a column for the quiz name. So we know there's 18 quizzes, but all they have is names. So in this table, in addition to the name, we have the date that quiz was actually given on. I mean, we assume that 18 quizzes, maybe there was one a week because semesters are 18 weeks long. But now we have the actual dates that each quiz was given. So now we can work with that. And, maybe you get better results on Monday because students are fresh. Maybe you get more absences on Friday, right? That would all be kind of reasonable questions to ask. So code chunk number 18, we have that table that we just imported, and the quiz name is identical to our quiz data, right? So we cleaned it up, we made it lowercase, got rid of the underscores, and now we're joining it in, and we have a new table called SS underscore dates underscore TBL. And here you can see that we have our usual suspects, the student ID, the treatment group, the name of the quiz, the date of the quiz, and the score, right? But now we have a date column. This is a real bona fide date column. It's not text value that could be interpreted as a date. It's a real date column. And R has lots and lots of functions that you can use to pull out dates, to plot the dates, to take the differences of dates, as you might imagine. There's a whole lot you can do with time series data. Go ahead into code chunk number 19 and run that. And what we're doing here is we're actually plotting the mean of each quiz, as well as plus and minus a single standard deviation as a time series, right? So not just like as different quiz 1 is a different box plot than quiz 2, but an actual time series. And we don't see the little points where there were actually quiz values because we're using a line graph here, but we could add those on there as well. It does look like the quizzes, just like looking at the bumps and the curves, it does look like the quizzes were generally spread out over the semester. Okay. But that's something we can do. We couldn't do that before. You can't do this kind of plot without actual data. The other thing you can do with when you have date or date time values is pull out the date parts. So in code check number 20, look at code check number 20. This is kind of interesting here. So basically, we want to get how many missing values, right? What is the proportion of missing values grouped by month, right? So January up through May. And the way we're doing that is we're taking this data that now has the quiz date on it, and we're grouping on that. But if you look at the group by expression, we're actually kind of computing on the fly the month of each date. So the Luber date has a function called month. You feed it the date, it gives you back the month. But we're not saving that as a column and then grouping it. It's included, that expression is part of the group by. So we're kind of like computing that and grouping it on the fly. And then for each one of those, we're simply computing the proportion of scores because they're going to be different, right? January was a short month. So maybe there's only 2 quizzes there. April probably had 4 quizzes. But we're computing the proportion of NA values over all of the values to get the proportions. So it looks like March had the most missing values. That's kind of interesting. Maybe that was spring break week and students took off a little bit early. Okay, then we have code chunk number 21, which day of the week had the highest quiz score? Because we only have a couple minutes to go here. Why don't I leave that one here? You can think about it. Those of you who are interested in taking the challenge, can try that. So I think that brings us to the end. Yep, that's it. All right, so I will pause there and thank you everyone again for coming to the workshop today and last week. And I think we covered quite a bit actually. If anybody has a data wrangling task that we didn't cover, I would love to hear about it because I like to teach things that are actual problems. But we learned how to like split columns. We learned how to reshape data. We learned how to resample data. Thank you for coming and enjoy the rest of your day.